Hi, welcome to today's lesson. Today's lesson is called reaction profiles. So last lesson we talked about endothermic and exothermic reactions, and today we're going to be developing that knowledge a little bit further. So before we start, can you complete the starter activity, which is just to write down what the words exothermic and endothermic mean based on your work from last lesson. Okay, so pause the video. If you're following along on the worksheet, just pause the video and answer the first question. Okay, so you should have answered that first question by now. So now we're going to just do a little bit of retrieval practice. I'm going to just move myself. There we go. So we're going to do a little bit of retrieval practice. So again, if you're following along on the worksheet, there's the coloured in squares for you to answer these questions. So there's 6 questions here for you to have a little go at. So based on last lesson, last week, and further back in the year. So I know you hate retrieval practice and I know you're not keen to get on with this, but really, really important to pause the video and have a go and try and bring that memory back that you have learnt this previous content. Okay, so pause the video and have a go. Okay, so well done. Hopefully you've had a go. If you haven't, pause the video now and have a go, please, because it's really important. Okay, and I'm just going to show you the answers. Okay, so here's the answers. You can go through each of the questions, maybe rewind the video and just make sure you've got those answers. So today we're looking at reaction profiles. So this is the bit from the specification about what you need to know. You need to be able to draw energy level diagrams for exothermic and endothermic reactions. So if you don't know what an exothermic reaction is and an endothermic reaction, please go back to your notes from last lesson before you continue any further. Okay, so we're going to look at exothermic and endothermic reactions, be able to draw reaction profiles, label those reaction profiles, and identify whether a reaction profile is exothermic or endothermic. Okay, you also need to know what activation energy is. Okay, so collision theory. So when a reaction happens, when molecules collide, a successful collision will mean that a chemical reaction has taken place. Not all collisions are successful though. Okay, the reactants have to actually collide, they have to actually hit each other in order for the reaction to happen, but also they need to have enough energy in order to react. So the energy they need in order to react is called the activation energy. Okay, so here's your first thing to do. Again, this is on the worksheet. Explain why there's more collisions if there's more particles in the same box. Include a diagram. So pause, have a go at this question. Okay, so you should have drawn some particles. You should have been able to explain that the fact that there's more particles in that box, then there is more likely that the collisions are to occur because in a smaller surface area, in a smaller space. Okay, for 2 marks. Right, so activation energy. Activation is the minimum amount of energy required in order for the particles to collide, to undergo a reaction. Okay, so again, if you're following along on the worksheet, please make sure you've completed that question, what is activation energy? And a reaction profile looks a bit like the picture I've got in front of you. Again, this is also on the worksheet. Please, while we're going through these notes, can you label up the reaction profile with the right labels? So the activation energy is the minimum amount of energy needed for a successful collision. So here you can see this here is how much energy the reactants have before they react. This here is the activation energy. That's how much energy is needed in order for a chemical reaction to occur. And this here is the amount of energy that the products will have. So the difference between the energy that they started with and the energy that they ended with is how much energy is given out in a reaction. Okay, so we're going to go through that a little bit more. Okay, so we said this is the starting energy level that the reactants have. This is the activation energy. This is the amount of energy that's needed. So it's between 45 to 103 kilojoules. So how much energy is the activation energy in this example? Okay, not always the same, but this is just an example. So we've got the reactants, how much energy the reaction started with. We've got the activation energy, okay, which is between these 2 dotted lines. Then we've got the energy of the products. And the overall energy change is between this 10 kilojoules, which is the reactant, the energy of the product, and the energy of the reactant. So the difference between 10 kilojoules and 45 kilojoules is the overall energy change in this reaction. Now, energy is needed to make bonds. To make bonds. To break bonds, it releases energy. Okay, so the difference between the reactants and the products is how much energy changes. It's how much energy is given out in a reaction or taken in a reaction, whether it's endothermic or exothermic. So here we can see the energy of the reactants, the energy needed, the activation energy for that chemical reaction to happen, and how much energy is therefore transferred into the surroundings. So in this example, you would heat it up to give it that extra energy to get that chemical reaction going, and then afterwards we'd find that the products would have less energy than the reactants. So energy was given out in this example. So if energy is given out in a chemical reaction, then it is an exothermic reaction, okay? The energy is given out, it's exothermic. If the products have less energy, if they're the products, the line is up here, so that they've got higher energy than their reactants, then it's an endothermic reaction. So we're going to look at what that means now. We see here, so our products have higher energy than the reactants that they started with. So the activation energy is still this energy difference here to get the reaction going, but our products have more energy than our reactants, which means it's absorbed energy from the chemical reaction. Therefore, it's an endothermic reaction. Okay, so we've looked at the different profiles for an exothermic and endothermic reaction. Okay, so here we've got two reaction profiles. Are they endothermic or exothermic? Well, the products are higher than the reactants, so they are endothermic reactants. The activation energy is between the reactants and the getting going up here. Okay, so you can see the different types of reaction profiles here. We've got this one requires much more energy than this one, and this is to boil ice cubes, whereas this is to boil water. Okay, so exothermic, the reactants have more energy than the products. The products are much lower. Endothermic, the products have more energy than the reactants. Okay, so an exothermic reaction, the products will be lower down. They have less energy than the reactants that they started with because energy would have been given out. Whereas endothermic, the products will be higher than the reactant because energy is taken in during the reaction. And finally, for this lesson, can you complete the exit task attached to the lesson? Okay, well done. Thank you for showing up. Great work today.